the definite integral, example 1. Sketch the graph of y equals e to the x in the interval from 0 to 2 and shade the area described by the integral from 0 to 2 of e to the x dx. So we're going to need some axes. So here's x and here's y. Now e to the 0 we know is 1, and then e to the power 2 is, well, let's just call it e squared, since it was not going to be a nice value. And we know the shape of an exponential function, so we know it's going to go like this, and the area that's described by 0 to 2 of e to the x would be this area here, trapped between the curve and the x-axis. We want to use technology to calculate the lower and upper rectangle sums for n is equal to 100, 500, 1000. Okay, so that's going to take us a little while to do, and I'm going to use Excel in order to do that. So for the first one, with n equal to 100, we know that the gap here is 2, so 2 divided by 100 is 0.02. That's going to be the width of our rectangles. So we'll start with the lower end being 0, and then what we're going to have to do is say equals the one above, and then we're going to add 0.02, and that's going to give us our x coordinates. So what I'm going to do is I'm just going to fill that down quite a way until I get to 2. And not quite, what have I done wrong? So, oh, it's done it now. Okay, so fill it down till we get to 2. So that will just be there. Let's just clear those ones. Just want to clear those ones. I'll just get rid of them. And then we want the corresponding y values. So that's going to be the exponential function. So let's type in exp, and there we go, that will be the exp function, and the number will be the one next to it. So what we're doing there is getting the corresponding y value. We know that when x is 0, y is 1, and if we just double click on that square there, it will fill it all the way down for us. So those will be the heights of the rectangles. Now remember, this one is sloping upwards, so for the under rectangles we're going to take the left hand ends. So the area of this first rectangle, remember the width is 0.02, is going to be equals 0.02 multiplied by the height. And let's fill all of those down. And then our lower estimate we can get by doing a sum of the 100 under rectangles. So that's going to be equals, and let's just type in SUM, and then we need to open bracket, and we'll get that, and we'll just drag it all the way down. I think I might need to get rid of the keyboard. So let's start again. Drag it all the way down, and what we're not going to do is take that last rectangle and so that's that, and if we just enter on that one, that gives us our lower estimate. And then in actual fact, I think if I just fill that down one box, it will automatically take from there right the way down to the bottom. So that's our lower estimate, and that's our upper estimate. And then what we need to do is just repeat that process with the 500 and the 1000. I'm actually going to stop recording while I do that because you don't need to see that whole process. Okay, so I've now done the 500 and the 1000, and we can see the results for the 100, the 500 and the 1000 here. And notice how the interval is getting smaller each time. So 6.325, 6.453. So we know the areas between those values, but this is a smaller interval, and this is a smaller interval yet. So this one is our best estimate because it used the most rectangles. So 6.382669 is the smaller figure there. So that was I've forgotten what it was now. So we just need to quickly get that back. 6.382669. 382,669, and the upper interval there was 6.395, 6.395447, 6.395447, and we're asked to state this correct to three significant figures. Well, we can't actually do that because to three significant figures, this one is 6.38, this one is 6.40. We just can't use those figures to give us three significant figures. The best we could do here is two significant figures giving us 6. So that would round to 6.4, this would round to 6.4. So 6.4 correct to two significant figures, so 6.4 square units. So we couldn't actually do that with the information given. You could, of course, average these two to give a better estimate, but we don't know whereabouts that better estimate is, so you still couldn't give it to three significant figures because it might be closer to this one, it might be closer to this one. We're not exactly sure. So the best we can do here is two significant figures. So always be aware of that. In order to use an interval to give you an answer to three significant figures, both the lower and upper bound need to both round to the same thing correct to three significant figures.